Welcome to Industries in Chemical Engineering, a series of short videos intended to expose sophomore chemical engineers to the variety of career options available within chemical engineering. I'm your host, Dr. V.J. Tocco from the Department of Chemical Engineering at the University of Florida. Just a reminder, all information presented here comes from my own experiences, discussion with engineers in these fields, and my own curiosity. You should expect your experiences in these fields to vary considerably. This is Industries in Chemical Engineering. Epilogue Graduate School. Quickly before I begin, I want to note that graduate school can mean many things for the undergraduate chemical engineer. Several of my friends and former students have moved on to careers in other fields, including business, medicine, and law, and are finding that their technical backgrounds put them in a position to succeed. Yet, this presentation is solely about getting a Ph.D. in chemical engineering. I have to admit my bias for this path because this was the one that I chose. I also have to admit that I heard a similar presentation about grad school when I was a sophomore in my material balances class, and at the time I was certain that I absolutely did not want to get my Ph.D. Needless to say, things changed. So I encourage you to watch and remember this presentation, even if you think it doesn't apply to you now, because it might in the future. Starting off with what exactly is a Ph.D.? It is a degree program that is of indeterminate length, but usually somewhere between 4 and 5 years. A minimum of 4 more years of school can sound very unappealing, especially after you're finished with the gauntlet of the undergraduate chemical engineering curriculum. But the Ph.D. is not really like the schoolwork that you're used to. At UF, for example, there are only 8 classes that you need to take in total. At least half of them you'll take in your first year. The bulk of your time in grad school will be spent performing research, in which you conceive and perform your own experiments, with the goal of stretching the current boundaries of humankind knowledge. At the beginning, you'll be matched with a faculty advisor, a professor with expertise in a certain field. They will guide you at first and help you to get started in defining your own research problem, but they also expect that you'll become independent by your 3rd or 4th year. The conclusion of the Ph.D. is the submission of your thesis, also known as dissertation, which is a book-length paper about the discoveries that you've made, and your thesis defense, which is an oral presentation about the highlights of your research to your advisory committee. This is one of my favorite cartoons about Ph.D. life, which spoofs the old sports adage that the best offense is a good defense. This one turns it around to say the best thesis defense is a good thesis offense. The reason why the length of the Ph.D. program is uncertain is because you're only finished when your advisor and you agree that you've made significant advances towards stretching the boundaries of human knowledge. This uncertainty can be stressful, but don't let it deter you. Who are good candidates for a Ph.D.? It is certainly not for the faint of heart. The best Ph.D. students are highly self-motivated and able to handle frustration and failure. When things go wrong, which they inevitably will, you must be organized and good at troubleshooting. Even successful science is useless if it isn't published. For this reason, being a good communicator is also essential. Notice that I did not say that natural intelligence is a prerequisite of successful Ph.D. students. Paradoxically, I actually believe that the best Ph.D. students are the ones that have gotten a few bad grades, because it suggests that they're used to working hard for their grades, and it also means that they've experienced what it's like to fail and have kept working. Also, a Ph.D. requires a different kind of intelligence than the type that is measured by grades. Ph.D. intelligence is mixed with creativity and ingenuity. That said, GPA is a criteria evaluated during the admissions process. To me, it should have much less weight than it does, but anything above a 3.5 should make you competitive. I fully acknowledge that some of the things I've said so far might not make you very eager to pursue a Ph.D. So next I'd like to talk about why you should. For me, the #1 reason and benefit is that you get much more freedom and autonomy in your future work. Basically, a Ph.D. says that you can be trusted to manage yourself and put out quality work without someone else telling you what to do. Second is that a Ph.D. opens doors to different types of jobs, for example in research and development or in academia. Be aware, though, that these jobs can be highly competitive and that the Ph.D. can close other doors as well. There aren't many Ph.D. chemical engineers who work in process engineering, for example. Not to say it's not possible, just that it's not very common. Along with the idea of different types of jobs, these jobs are theoretically higher paying than the jobs that you would get with a bachelor's in chemical engineering. But you have to factor in the opportunity costs of spending 4 to 5 years in graduate school versus building a career at a company and possibly getting promoted. On the other hand, a PhD in chemical engineering typically does not have a cost. Most schools pay your tuition and on top of that offer a stipend of $25,000 to $35,000 per year. I thought it was very cool that I got paid to essentially develop myself as a thinker, scientist, and a communicator as a PhD student. My fifth reason is simply because you can. Because you are a motivated, naturally curious person who seeks to understand the way the world works and contribute to the ever-growing pool of human knowledge. My sixth reason should absolutely not be the reason why you choose to do a PhD, but it's a nice side benefit nonetheless, that your family and friends will be very proud and impressed. You can even request to be called doctor. There are two schools of thought when considering the decision of when to do your PhD. I'd say the more common path is to dive in right after undergrad. And this is because you're still in the school mode. You'll probably also have to move somewhere and spend a lot of time in your future lab, so it helps to knock it out before you've started a family and settled down. Not that it's impossible to do if you've already done these things, just easier. And finally, because you've had no taste of the benefits of the working life as a chemical engineer. No fat paychecks, no working during your free time, and no constant nagging in the back of your mind about the length of your to-do list. However, some PhD students come back after a few years of working in industry. Those who do come back are well equipped and positioned for success, owing to an increase in maturity and a broader perspective of how things work. Additionally, since they are making the choice to take a pay cut to come back to school, these students have a clear vision in mind for what comes next. Next, I'll discuss how to choose a school. Some examples of really good schools are NC State, Texas, Virginia Tech, UC Santa Barbara, Georgia Tech, Delaware, Texas A&M, Colorado School of Mines, UC Boulder, and of course my alma mater, Michigan. I want to be clear that this list are only examples and my omission of any schools is only because of space and not intended to be a slight. There are plenty of great schools to go to grad school in chemical engineering. You may notice that Florida is conspicuously absent on this list by design. Not because it isn't a great school, but because the only school that you should not consider is your undergrad institution, unless you have a very good and specific reason for wanting to stay. You'll see that every school is slightly different, and venturing outside of your comfort zone is usually seen as a positive. There are several strategies that I'd recommend for choosing a grad school, including checking the rankings published by U.S. News and World Reports, and visiting the grad school fair that occurs at the annual AICHE conference. Another strategy is visiting the websites of schools you'd like to attend, specifically the pages for the chemical engineering departments. As an example, the UF Chemical Engineering website is located at www.che.ufl.edu. All department web pages have a place that you can see the faculty. And hey look, there's me. And we'll have an external web page for their own research labs. For example, let's look at my friend Dr. Jang's lab web page. There's a research tab where you can go and read about the projects that are going on right now. If you're interested, you should reach out to these professors and ask them if there's an open position. Okay, hopefully I've convinced you to at least keep grad school open as an option. What is the best way to do so? For better or for worse, GPA will be a requirement and you should aim to keep your GPA high. You never know how schools factor in GPA or academic performance, so it behooves you to do your absolute best. You should also seek an undergraduate research experience as early as right now. Just like with the Career Showcase, don't be discouraged by a lack of experience. Your enthusiasm matters much more. You also probably won't learn much about the specifics of your research topic in a course, and furthermore, you won't be independent when you first start. However, if you're serious about grad school and research, you should aim to spend multiple semesters in your lab, learning more each time, and aim to get as independent as you can by the end. Thinking of your own experiments, collecting your own data, and analyzing it yourself will help you decide if research really is the path that you want to choose. You should schedule the GRE, which is a standardized test required for graduate school admissions, approximately in the summer before you intend to enroll. Applications are usually due by the end of fall semester or at the very beginning of spring semester. I recommend applying to many schools because the admissions can get quite competitive. I only got admitted to half the schools I applied to. The spring semester is the fun part. You'll get invited to spend a weekend at each school that you get admitted to, where you'll meet the faculty, discuss potential research projects, and get a tour of the town. This is another reason to apply to many more schools than you think you need. I'll be very honest that UF was not my first choice of graduate school at the beginning, and that I got accepted to my dream school of Georgia Tech. Yet, after visiting both schools, I instantly felt like a part of the UF community, and felt a connection to many potential advisors that made my decision unexpectedly very easy. I'll conclude this episode here by mentioning that I'd love to answer any additional questions that you have by email if you're thinking that grad school might be for you. As always, thanks for watching.